Okay, so the log law tells you that if you times the inside the log of the multiplication or log of a product will be the equivalent of the addition. Now this is the inverse of exponential. Remember, exponential was e to the power of, oh my god. Exponential was e to the power, not e, let's do 3 to the power of 2 times 3 to the power of 5. So when you times them, you say, you add the powers. So it's 3 to the power of 2 plus 5. Now it's very similar. It's log m of 2 times 5 is the same thing as saying log of n 2 plus log m of 5. Does that make sense? So it's sort of, it follows the same concept. The difference is the timesing is two separate terms and it comes to one term. This one is one term to two because it's the inverse. Okay, it's the inverse. So it has to be the other way around. Okay, but it still follows the same concept. You times, you add. If you divide, you subtract. And it's the same thing over here. So now they're saying logarithm of quotient, which means division. M divided by n is just the difference between m and n. That's why it's very similar to your exponential. Okay, because whatever you do for the exponential, you're going to do for your log. It's just the inverse. Yeah? Okay, now I'm going to show, in the next slide, I'm going to show you why this rule is true, and it just follows from your exponentials. Okay? But the examples on the bottom is just to get you to understand how the rule works. So for rule number 1, let's say you got log of base 2, 3 times 2, then this is another way of writing this is log base 2 of 3, not multiply, add with log base 2 of 2. Okay, now I don't know what the answers are. Like actually, I do know what log 2 of 2 is. What's log 2 of 2? 1. Good. Okay, but I don't know what 2 to the power of something gives you 3. I have no idea what it is. Okay, some sort of fractional power. Okay. Okay, so you can just leave it as log 2, 3 plus 1. Yeah? Second one. You don't have to. No, you don't. This is just me trying to explain it to you. If you get it, great. It's the next one that I want you to copy down. Okay, so same thing with this one. This is the same thing as saying 2 times x minus 2. So if you break it up, then it will just be log base 2 of 2 plus log base 2 of x minus 2. Okay, because you just do the multiplication of 2 and x minus 2. Then when you split it, it becomes 2 and x minus 2. Okay, same thing with division. Division would be subtraction. So this would be log base 2 of 5, take away log base 2 of 10. Okay, same thing. Sorry? If you're trying to solve for x, you will be doing, but not yet. This is just simplifying. You can only solve if it's an equation. That's not an equation, that's an expression. That's why you can't solve it. Okay? Alright, let's go on to... Oh, what? Sorry. I'll finish off this last one too. No, I'm just waiting for people to copy. No, the tip busted. I've been using it for so long, and I was gonna go buy a new one, but I'm like, wait, I have a free, like I have one at home, because initially I had one that was grey, and that broke down, and so they needed to give me a replacement. So in that time, it took them like a week before they did that. I bought myself one, and then they gave me a replacement, so I got 2. So I thought, instead of buying a new tip, why don't I just use this pen? In fact, I probably should have just switched out the tip.
Yeah, I was gonna say because I know when I bought mine,
Yeah, I don't know where that little box is. One disappeared. I don't need it now. It's all good now. All right, here we go. Next one. So where the log rules come from, you don't need to know this. I'm just showing you so you don't feel that it's totally out of the blue. and why it links back to exponentials. Okay, so let's think of this way. Log A of m. I don't know what log A of m is, but let's just say it was equal to x, and log A of n is equal to y. Okay, so I'm just getting these letters. So log A of m. No, you don't need it. No. So log A of m and log A of n. Yeah? So I don't know what these values are. I'm just going to call them x, and I'm going to call them y. So a to the power of something, or a to the power of x, is equal to m. And in this case here, a to the power of y equals n. Now what I just said to you is how I'm reading my logs. I'm reading it as an exponential because I like to read it as exponentials. And because we learnt exponentials from 7, 8, 9, and 10, it's easier to read it this way rather than reading it that way. Okay, so if I rewrite it, I'm like, well, this is equal to something, but I can read it as a to the power of whatever that something is equal to n. So I'm going to rewrite that again. A to the power of y equals to n. Now the nice thing about this is if I use my exponential rules, because they're talking about multiplication, then if I said, what if I got m, which is this number, times n, because that's what this is, m times n, okay? M times n is the same thing as saying a to the power of x times a to the power of y. Agreed? Yeah, I'm just using exponential laws. I'm just converting what that is. So converting a log to an exponential, converting a log to an exponential. This part here says m times n, so I'm like, all right, m times n is the same thing as saying a to the power of x times a to the power of y. Using exponential rules, I know that if you multiply them and they have the same bases, you add the powers. So that's what I'm doing. I'm saying, all right, a to the power of x plus y, x plus y is what I have. Now, from here, what does this mean? It means m times n is equivalent to a to the power of x plus y. Okay? Now here's the thing. If m times n equals a to the power of x plus y, then I can rewrite this now, and this is where it gets interesting. See, if we read this is an exponential. A to the power of something equals that. Now, yeah, exactly. It's exactly the same what we did here. A to the power of something equals n.
So would it be log to the log a to the power of n? Maybe you should.
No, you're right. So, if you think about it, log a of mn, or a to the power of x plus y, equals mn. See what I'm doing there? I know the letters are confusing, but if you think about it, it's exactly the same thing as this. A to the power of y equals n. A to the power of y equals n. If we reverse it, it's just saying log a of n equals y. This is why I don't like the way the textbook does it, because if you're going to try to do what I'm just doing, teaching you right now, it's a lot confusing because you're like, where do I move it? Where does it go to bottom or top? Don't. See, at this step here, this is what I want you to do, what I taught you previously. mn equals a to the power of x plus y. True? Do the inverse. See, this is exponential base to the power of.
Why don't you just color code it?
Well, what do you mean?
So like two forms and you put them both in the same colors each palm.
Oh, you can. But I'd rather teach you, instead of like color coding, I'd rather teach you the mathematics to it. So the mathematics here, balance in the equation. Opposite of exponential power is log. So I'll just do log both sides. If I log both sides, see, that's exactly what I taught you in the previous slide.
And then a goes away.
Yeah, because log a of a are inverses. It's like saying times 2, divide 2. Add 2, take away 2. So that's all I'm doing here. So in a to the power of, then log a. Then I log a on both sides. And the convenience is log a and a cancels out. Now you're left with x plus y is equal to log a mn. See, there's no confusion. There's no, oh, do I switch it here? Does this go to the bottom? Does this go to the top? None of that. It's just a simple idea of what I taught you previously on this slide. So on this, whoops, where do I go? I want to go to this slide. Remember with, I chose the wrong one. Remember this one? When I was trying to teach you, I was saying, don't try to move it the way the textbook teaches you. Try to understand it as, if it's 3 to the power of, then I did log base 3. Okay, so I did log base 3 on both sides. Log 3 and 3 will cancel out because they're inverses of one another. That is no different from what I'm doing with you. Which slide is it? I think it's this one. Is it here?
Yeah.
Oh, there it is. There's no difference. Oh, here. Same concept. You had the a, so if I just remove this, same thing. Instead of 3 to the power of 2, you got the base a, so then I just say log a on both sides. So log a and a cancels out, and you've got log mn equals x plus y. And that's much easier to understand than it is to try to move to convert, because that's how your textbooks will teach you. I'm trying to teach you through the algebra. Okay, so you're still balancing the equation, you're just doing inverse of exponentials. Yeah? Having said that, so the next slide, so if we follow what I was just saying before, so we get to this stage, we're like, all right, log a of mn equals x plus y. And now, we can now say, well, log of a mn, now this is log of a mn is equal to x, which you wrote here, x is log a of m, plus y, which is log a of n. So if I just take this, and I substitute it back here, and I took this, and I substitute it back here, that's where the rule comes from. Okay? And if you do exactly the same concept for division, it's the same thing. See, if you just do for division, if I just rub this one off, it's the same concept. So division, I will be saying this. I'll be saying log a of m is equal to something. So I'm like x, log a of n equals to y. And then if I reread this, I said that a to the power of x equals m, a to the power of y equals n, okay? And then I said, well, m divided by n, so m divided by n is the same thing as saying m, which is a to the power of x. Yeah, exactly. And it's the same concept again. You're back to m divided by n is equal to a to the power of x minus y. And right here, see, there's no need to memorize how to convert it. It's just balancing the equation. See, I've got a power of a, base a. To remove that, I'm just going to do log base a on both sides. See, if I log base a on both sides, log a and a cancels out. And that gives me x minus y, log base a of m and n. There's no reading, there's no memorizing here. It's all just inverses. Base a to the power of something, log it. Okay? And then from here, x, which is that, y, which is that, and that's where the two rules come from. Okay? But what was the key thing was being able to read what log am equals x means. Because a lot of students don't know what that means. They just write it, but they have no idea what it means. Okay, so if you understand it, that means sketching it also makes more sense too. Okay, so it's just reading how to find the power of x. That's what you're trying to do. Okay, a to the power of something equals m. That's what you're really saying. All right. Those are your two rules. So you got law 1, law 2. So what's the next 2, 3, and 4? It all comes from the same thing. So you can do exactly what I just showed you over here, and you can figure out the rules yourself as well. Okay? But here we go. 3 and 4, all they're trying to say, which technically you don't even need 4, you just need 3, because 4 comes from 3. Okay? What 3 is trying to say is if you have log a of m to the power of p, you can take the power down. Yeah, and it just becomes p times log a of m. But this is almost obvious because remember previously when I taught you log 3 of 3 equals to x, right? We all know the answer is 1. Log 3 of 3 is 1. But if I told you to rewrite this, this is the same thing as saying 3 to the power of x, which equals 3, which you knew x has to be 1, true? If you think about it, if I change this to 9, and I made that as an x, okay? That just basically, oh, no, I shouldn't do that way. I should do this too, sorry. Then this is like saying 3 to the power of 2 equals x, true? And so that we know that this is 9. Now let's switch that around. What if I then did this? What if I then did, let's not do 3, let's do 2, 2 is easier. Let's do 8, okay? If I did 8, another way of writing this is log 2 of 2 to the power of 3. Agreed? Yeah, so this is looking very similar to this one. Log a which is 2, m, in this case, is 2 to the power of 3. Now, what I taught you previously was I said log 2 of base 2 cancels out, because they're inverses of one another, and the answer is 3. True? All they're saying is that, well, why don't you drop the 3 down 3 times, and now you got log 2 of 2, which we knew cancels out to be 1, and it's the same thing. That's all they're trying to say. Okay, so the logic, you don't need to have known that rule to be able to do that. You already did that with me prior to this. It's just that I would have cancelled these 2 out. Okay? It's just that sometimes you can't cancel it out, then it's nice. Like if it was a 3, like it was a 7 here, then at least you know you can bring the power down. Okay? If you're wondering why, it's the same thing again. You can do, if log a of m is equal to something, and I don't know what it equals to, okay? If I reread it, it's saying a to the power of x equals m. Then if you said m to the power of p, okay, because that's m to the power of p, then it's ax to the power of p, and then that now becomes a to the power of x times p. Yeah? Now if you rewrite it, m to the power of p is a to the power of x times p. Yeah? This can be rewritten as, and it's the same drill, same thing you've been doing. Log a on both sides, so then you're left with x times p is equal to log a of mp. Yeah, I'm just doing balance in the equation. So this is the only key step that you need to understand. Log base a, log base m, balance in the equation. Log base a of a cancels out, and you've got x times p, log a of m to the power of p. So now, log a of mp, which is this, you want it to be p times log a of m, which is true, because p times x, this is x. That's where the formula comes from. But you can see the technique that I'm using. All I've done is I'm using exponentials. Whatever you know from index laws, I can derive the rules. And if you follow the same thing, if it's -1, then you bring -1 down. Obviously, it's log a of m. Okay? So everything comes back to exponential rules. So log, just try to treat it as an exponential. The more you treat it like an exponential, the easier it is to understand logs. Okay? All right, there you go. So for today's session, we're going to try to solve. Okay, so let's do some examples and then I'll get you to do it. Practice the questions. Okay? Let's do this one. Let's do A. Log base 5 of x equals 3. What I want you to do is read it as an exponential. So if you were to read this as an exponential, what would this be? Yeah, 5 to the power 3 equals x. Now, I don't know what that is. That's 125 actually. Yes, 125. Done. Okay, so if you read as an exponential, it makes it so much easier. Okay, yeah. Okay, let's say, no, this is a good question. Listening. Alternatively, instead of reading it, remember, I don't want you to memorize, so if you don't want to memorize as well, it's the same concept. Remember, the inverse of log is exponential. Inverse of exponential is log. So right here, you got a log base 5. So the opposite of log base 5 is 5 to the power of. So if I said 5 to the power of whatever that is, and 5 to the power of whatever that is. See, I'm doing on the left, I'm doing on the right. 5 to the power of these log 5 should cancel out. What are you left with? X is equal to 5 to the power 3. You can read it as 5 to the power of 3 is equal to x. Yeah. Okay, but that's what I'm saying. It's just the same algebra. It's like saying if you had x times 2 equals to 8. What you would have done is you would have said divide 2, divide 2. It's like saying if I said x divide 2 equals 8, what you would have done is you said times 2 times 2. There's no difference. See, in this case here, if I had log 2 of x equals to 8, right, then all I'm doing is I'm saying opposite of log 2 is 2 to the power of. That's why it's confusing, because there's no symbol for it. The positioning is the symbol. So this one was easy because times was divide. That's a 2, that's a 2. This is the 2, but this is your symbol. Log is the time symbol. And then the inverse of that is the positioning. That's why it looks difficult. Okay, so these were easy because times, divide, times, divide. You could figure out the inverse operation. This one, the operation is the positioning. That's why it looks funny, and that's why it's harder to pick up. But it's the same thing. If it's log 2, operation, number, then the operation for this is position. Okay, so 2 to the power of that. So these two cancel out, just like times 2 and divide 2, just like 2 and 2. They all cancel out just the same way as 2 to the power of log base 2. Okay, so if you type in your calculator, even test it, if you did 2 to the power of log base 2 of x, the answer should just be x. Okay, because it's like saying on your calculator, x times 2 divide 2. It'll be x. Okay? So that's how you do those exponential logs. Try to balance the equation. Don't try to convert. Don't try to convert. Okay? So that was A. Let's try something a bit more tricky. Let's do the last one, D. Okay? Let's do D. Same thing, D. Now you have to combine all the laws that you have. So you've got two separate things here. You've got log 3 of x minus 1 plus. Now that's a key symbol there. Plus another log base 3 of x plus 1. Now what do we know?
Isn't that the first law?
First law, which tells us?
Which is the m and n equal times together.
Good. So if you remember the first law, log a of m times n is the same thing as saying log a of m plus log a of n. So in this case, my m is x minus 1 and my n is x plus 1. So I can rewrite this whole left-hand side as log base 3 of x minus 1 times x plus 1. See what I'm doing there? I'm just using law number 1. Okay, law number 1, I can say it's log 3 of this times this. That's all I'm doing. So x minus 1 times x plus 1. That's what I'm doing here. Okay?
Why don't you put double brackets?
I use double brackets so it's clear to you that you always have, when you do a log, there's always a bracket. Because sometimes in year 12s, I'll see my students, they'll just write their answers log 3. It's like sine as well. Sine of 3x. Some of them just think that the sine is a number itself or something, and they're like, cancel sine. So they say, divide sine. And it cancels out. You know, like, it doesn't make sense. Sine of what? See, sine is an operation. It's not a number. It's an operation. Okay, and this is the same thing. Log is an operation. So it's log operation of what's in it. And so that's why I'm using two double brackets there. Okay, so let's just come back to this. So double brackets log 3. Now, from here, like I said, if you want to solve things, you're always doing the inverse. So inverse of log 3, because that's the problem. I don't want log 3.
Should we get rid of the x? The first?
Get rid of the x.
Compress it.
Yeah, you can. You can. So if you compress it, x minus 1 times x plus 1 is x squared minus 1. Okay, so log, it's difference of perfect squares there. Okay.
Does it matter if you do that, or should you do the log first?
You should do the log first because it's,
The log first.
yeah, because it's log 3 of this. Okay, so you have to remove what's on the outside first before you move. It's like BODMAS.
The log.
Yeah?
Log first.
All right, so let's do the log first. So from here, we're going to remove that log 3. Inverse of log 3 is power of 3. So that's what I'm going to do. I'm going to do 3 to the power of this entire thing up here. Okay, I'll take away the brackets if it's confusing you. 3 to the power of this. And then 3 to the power of this.
So we're making it 3 to the power of 1.
Yes. Whereas these two cancel out.
You just didn't write the whole line out again.
Yeah. So this now becomes x minus 1 times x plus 1 is equal to 3 to the power of 1. See what I'm doing there? I'm just doing the inverse of log base 3. Yeah? So once I do the inverse of log base 3, these two cancel out. I've got the multiplication of these two is equal to 3. I know this is difference of perfect squares. X squared minus 1 equals to 3. Add 1 on both sides. Square root both sides. There's a problem to this one though. X can only equal to 4. Can anyone tell me why?
Because you can't have a negative.
Why can't you have a negative?
Because it can't cross the 0 line.
Sorry? Oh, sorry, it's 2. Thank you. Why can't you have a negative? Right now, we're just going to leave it there, but for now, just keep in mind you can't log a negative. You can't do this. You can't write log of -2. So you can have 3. You type in your calculator, that won't come up. It'll be undefined. It's like saying square root of a negative. For now, just keep that in mind. It's not until we get to graphs, then it makes sense to you. It's to do with your exponentials. Your exponential is above the y-axis, so you can't have y values that are negative. But for now, just stick to that understanding. You can't have a negative x value. Okay, can't log a negative. If the base was, yes. But if the base is a negative, then you don't have an exponential anymore. Yeah. All right, we'll leave it there.
Can you color code these now?
Color code which?
The thing is, the like, when you like swapping it.
When I swap it.
When you swap it.
I normally don't swap it.
When you change it from the log into the next one,
So like this one?
write it in index form.
Log, oh, I'll color code it? Is that what you mean? So 381. Let's say that equals to 4. That's 4. Okay, I'll use another color, sorry. Blue. Let's do, what other color can I use? Orange. 4. Yeah? Then it would be 3. So I'll do it here. 3 to the power of 4 equals
It has nothing to do with the log. When you arrange it, log's not really part of it. It's just the inverse.
because it's an operation. It's an operation. If it's log, the inverse will cancel out the log. If it's an exponential, the log will cancel out the power. They're inverse in one another. So if you think about it in the conversion, that's the color coding. So 3 to the power of 4 is 81. 3 to the power of 4 is 81. Yeah, that's why I don't want you guys to memorize it. Instead, I'd rather you work with the, yeah. But if you were to do it algebraically, remember 3 to the power of this, 3 to the power of that. If it's this side, log base 3 to both sides. That's always going to be a guarantee. But if you're going to try to shift things around the way the technique teaches you, you're bound to make a mistake at some point. Okay, so don't do that. Try to balance the equation. It makes more sense to why it works. Okay? I'll leave it there. I think you did some of these questions in the last exercise, but for those who weren't here, practice that. Then I'll switch to the next slide afterwards. Okay, but the next slides, you just want to practice law 1, law 2, law 3, law 4, and 5, and solving. I'm just going to stop the video.